Hi there, this is MJ on the journey back to Silicon Valley. Today we're going to look at problem 350 on LeetCode, intersection of two arrays. So, given two integer arrays, nums1 and nums2, return an array of their intersection. And basically the intersection is where there's a sequence of numbers that will have the same values both in nums1 and nums2. And we can see it here in this example. So the intersection here happens at 2, 2 in nums1 and also at 2, 2 for nums2. And the second example, the intersection is happening here, 4, 9 at nums1 and then also here in nums2. So my initial thought was to use a brute force approach with a nested for loop. So basically I will iterate over nums1 and nums2 and then push the smaller number to a temporary array. So create a temporary array, or you can call it result, and then push the smaller number to that. Now this approach didn't work because it did not take into account the fact that the arrays might not be sorted. So this will work if you compare numbers, you would push the smaller one to an external array, you can build a sorted array that way. But that's given that it's sorted. So it's not taking into account that the inputs may not be sorted. And also it's not taking into account that there could be duplicates. So the approach didn't work. The next thing I thought about, which was really interesting, this was actually my first problem that I've cracked under 45 minutes. My last problem has literally taken me 5 days because I just refused to look at a solution and like really my ego got into that, and it took me 5 days. And in this problem, I cracked it under 60 minutes, under 45 minutes to be more precise. And not only that, it was not a brute force solution. It was actually the most optimal solution. So I had an exponential learning experience. So yeah, the next thing I thought about is using a hash map to store all the elements in nums1 and then iterate over nums2 and check if an element from nums2 exists in that hash map. If it does, then we will push it to a result array. And here are the steps here. And let's go over the code. It might explain it. A little bit of housekeeping. I'm going to be reading from what you've seen on the screen is my personal blog. And it has a detailed article of the whole thought process. So I'm going to be reading from that. The blog link will be available in the description as well as the Medium article for this. So let's look at the code. So we're initializing an empty array called inner for intersection, and then we're initializing an empty map, and then we're iterating over nums1 and checking if an element is equal to undefined in the hash map, that means it doesn't exist, then we will assign that current element to the hash map key and then assign 1, which is going to be the occurrence. So we're going to keep track of the current element and also its occurrence, like how many times does it occur in the array. So if the element is not there, then we're going to add it to the array and then keep track of its occurrence. If it is there, we're going to increase its occurrence count. And then we're going to iterate over nums2 and then check if the map has that current element in nums2. And here we're using the hasOwn property built-in function. So if the element from nums2 is present in the hash map and its occurrence count is more than 0, then we will push it to the result array, push the current element, and we will decrease its occurrence count in the hash map. And this solution was accepted by LeetCode, and it has actually great time complexity because it's basically OM plus N, and M and N being both the lengths of both input arrays, nums1 and nums2. So because in the worst case scenario, we're going to have to iterate over the entirety of nums1 and the entirety of nums2. In terms of the space complexity, the space complexity is gonna depend on the bigger array. Now, I did think of optimizing actually when I'm building the hash map, I can iterate only over the smaller array to decrease the space complexity. However, the result array that we're gonna eventually return is gonna have to depend on the bigger array in the worst case. So even though like we can reduce the map space complexity to O min of Mn, like the space complexity of the map can depend only on the smaller array. But the result array is gonna have to depend on the bigger array. So it's gonna be max of Mn. A couple of optimizations I can introduce to this solution right here is, which also answers the follow-up question on the problem description in LeetCode. It says, what if nums1 size compared to nums2 is smaller? And so in this case, we can make sure that we iterate over in order to build the hash map, we can iterate over the smaller array. And that's gonna give us more space efficiency if we do that. And that is an answer to the follow-up question here. So I'm gonna be adding a condition to store only the smaller array in the hash map. And the second optimization is I'm gonna be using a JavaScript map object instead of using a regular object. So currently in the solution here, we're using a regular object, but I'm going to use JavaScript map object because it has tons of benefits. I think the most notable one to me was the ability to actually iterate directly over the map object versus iterating over an array that was created. So if you use the JavaScript map object, you can directly iterate over the object. If you're using a regular object, what's happening, actually you're creating an array and then iterating over that. And here it has a bunch of advantages of why to use actually a JavaScript map instead of a regular object. And like I mentioned, the ability to iterate directly was really interesting to me. And also, what's interesting here? It's yeah, it also guarantees. Can be a better. Yeah, it also. I'm not sure it guarantees an order or not, but in terms of performance, like if you have a lot of key value pairs, it's much more efficient to use a JavaScript map for it because like it's already built for that versus using a regular object. We can remove the key value using. Okay, yeah. So yeah, the most notable to me was the ability to actually iterate directly over the object versus like iterating over an array. But these are the benefits here. And so here's the modified version. So I've replaced inner with result. So in the last solution, the array was called inner. Here it's called result. So we're doing the same thing, initializing an empty array that's going to have our result. And then instead of using a regular object, we've rewritten the solution using the JavaScript map object. And one interesting thing here, this is the deconstructor syntax. What this is doing, so instead of having like a clunky if condition to check which of the input arrays is smaller, JavaScript, you can use destructuring syntax here to swap them. So if we notice that one array is smaller than the other, excuse me. If we notice that one array is smaller than the other, we can use destructuring to swap the contents of the arrays. So let's say, for example, nums1 turns out to be the smaller array. No, nums2 turns out to be the smaller array. Then we can swap the contents of nums2 into nums1 and then iterate over nums1 because it's a smaller array, and that will give us better space complexity, at least as far as the map, building the hash map is concerned. And okay, so next, okay, so there's another follow-up question in the problem description, and that is, so let's say your input arrays are already sorted. So if they are already sorted, using a hash map is no longer the most optimal solution. So if you have inputs that are already sorted, it's best to use a two-pointer technique, because we can iterate over the arrays only once. We can iterate over the arrays like one pass over the arrays, and we only have to store the resultant array. So there's no built-in of a hash map or anything like that. We're just going to use pointers to keep track of values in both nums1 and nums2. And the only thing that we're going to store actually is the result array. That will be the bulk of the space complexity. And here are the steps right here. So now I'm performing a sort here on nums1 and nums2, but that is just for demonstration purposes. This solution is most optimal only actually when the arrays are sorted. So if you're using this solution, your arrays are probably already sorted, but I'm sorting them here for demonstration purposes. So we're sorting nums1 and nums2, and then we're initializing two pointers, p1 and p2. And we're assigning 0 to them to start with. So 0 will be the index. Then we're iterating over, well, first we check if this condition is true. So while p1 and p2 are smaller than their respective arrays, then if we find a number that is a number in nums1 that is equal to a number in nums2, then we're going to push that element to the resultant array, and then we're going to increment both the pointers p1 and p2. Else, if an element in nums1 is smaller than an element in nums2, then we're going to increase the p1 counter. Otherwise, if an element in nums1 is bigger than an element in nums2, we're going to increment the p2 counter. And then we will return the result. So the solution was accepted on LeetCode. And an interesting thing worth to note, I think, here, if you use the .sort function without a comparative function in the arguments, it's not going to work properly. Okay? Some of you may already know that, but that was a discovery for me. So if we don't add a comparative function in the argument, then the default behavior would be like the order would not be sorted properly numerically. It's going to be 1, 10, 2, 20, 3, 30, and so on. So yeah, so to go through a recap, so basically the two most optimal solutions to solve this problem is a hash map implementation and a two-pointer technique in case your inputs are already sorted. So let's go over the hashmap implementation. So basically what we're doing with the hashmap, we're creating a hashmap to keep track of elements and their occurrence count. And that trick is what's handling actually the duplicates in our input array. So we're keeping track of the current element and its occurrence. Then we're iterating over the other array to check if an element is present in the hash map. If it is, then we push it to a result array. And the complexity is, in terms of time, is OM plus N, which is the length of both nums1 and nums2. And then the space complexity would be the minimum of the two arrays. It will be the smaller one, since that's, in the worst case scenario, the entire smaller array has to be stored into the result array. So it's all min of mn. So a good case for this approach is when your array is significantly smaller than the other. So there's a huge difference in length, and also the inputs are not sorted. So using a hash map is more efficient. Now, if your inputs are sorted, we can use a two-pointer implementation, because that would be the most optimal approach for this. So here are the steps. Bear in mind, the first step is just for demonstration purposes. You don't need to sort them, since if you are using this approach, most likely your inputs are already sorted. So the idea is to initialize two pointers, and these two pointers will keep track of the elements in nums1 and nums2. And we're using an algorithm here. So if they're equal, we push. If one is smaller than the other, then we increase the pointer that's on the smaller array. And and for the bigger array, we increase the counter. So if P1 is assigned to nums1, like it's iterated over nums1, P2 to nums2 respectively, then if nums1 element is less than nums2, then we increase the P1 counter. If nums1 is bigger, then we increase the P2 counter. And then we return the result. And doing it that way will give us the intersection at the end. In terms of complexity, now the time complexity, if you have to sort, then it's going to be O log excuse me. If you have to sort, that would be the most expensive operation, and it's going to run in n of log n. If you don't have to sort, which sort is actually for demonstration purposes here, you don't have to sort. So the time complexity would actually be just n of log n, and the log n would be the length of the output array, and then the space complexity would be O of 1, because we're only storing the result array and the pointers. So, and then a good approach a good case to use this particular approach is when both arrays have a similar size and are already sorted. So if they're pretty much the same size and your inputs are sorted, a two-pointer is the best approach. If the inputs are not sorted and you have a significant difference in their lengths, then a hash map is your best implementation. Yeah, that's it. And I think that does it for this problem. I hope this provided you value. If it did, please like and subscribe. And then until next time, this is MJ on the journey back to Silicon Valley.